There we go. We're live. Welcome to 2021, everyone. Today's date is 1/4/2021. 2020 set the bar real low. This should be a better year if we make it a better year, right? Our objective today is to do what with a quiet raised hand? Looks like Kira had it first.
Use rigid transformations to prove congruence.
There it is. So let's talk about those words that I used in the objective. A transformation. What is a transformation again? Can you guys give me like our 4 transformations that we've talked about over and over and over before, Charles?
Translation, rotation, reflection, and translation, rotation, reflection.
Sorry.
What's that 4th one?
The last rigid transformation. I'll give it to someone else.
All right, there's a bunch of hands to choose from.
Yeah, no, I don't want to choose. Let's go. I don't know, Jade, I guess.
Dilation.
There it is, dilation.
Wait, that's not the rigid one, right?
Yeah, it's not rigid, but it is a transformation.
Oh, sure.
Yeah, so a rigid transformation, as Charles was talking about, is different than a non-rigid transformation. A rigid transformation is a transformation or transformations, plural, that preserve these 2 things. What are those 2 things, Wyatt?
I was just going to say that we also learned about stretches and how it doesn't preserve like angles and lengths.
Exactly. If I just pull it this way, then that is not, that's another transformation. So you can say a horizontal stretch or a vertical stretch. I could put those in the transfer. I ran out of room though, but you're totally correct. Those are some other transformations that I could put in there. What is a rigid transformation while I have you on the phone here, Wyatt?
It's a transformation that preserves angles and I want to say lengths.
That is correct. Yeah, angles and lengths. And there's only 3 of those that we know of: translation, rotation, reflection, those ones that Charles has down really well. So proving congruence. If a shape can be mapped onto another shape only using that previous word that I talked about, then the 2 shapes are congruent. And I think I've talked about that briefly, but we're going to be using that more and more. Have we like done this unit? This feels like we have not done this.
We did go over transformations and like copying them and stuff like that.
Yes. Okay. I'm just making sure we haven't done this unit because this feels like it's so much review. Yes. If you're using what are the things that you can use to, what are these blanks to prove that shapes are congruent? What's that vocab word that we just talked up above that has 2 words in the vocab definition?
Rigid. Oh,
Yeah, Asha.
rigid transformation.
There it is. Rigid transformation. Oh my gosh, handwriting nations. That needs to be my New Year's resolution, how to write better. Yeah, so if you can use a translation, rotation, or reflection to get one from one shape to another, then those shapes are proven to be congruent. So these 2 shapes right here, let's go ahead and use some transformations and see if they are congruent. If you just eyeball them, I'm going to be like, sure, yeah, they look good, but let's prove it. Again, geometry, the what is kind of the easy part. The why is the hard part. Why are they congruent? So how am I going to map one shape onto the other? Let's say I'm going to try to map this blue triangle DEF onto this red triangle using some transformation. So we're going to have some steps over here. First step, what should we do here? How do I start this off? Yeah, Kira?
I think so. You could like do a translation of 2 to the left and 1 down.
Perfect. So translate 2 left, 1 down. Okay, let me see if I can do that. So that means my point D prime is here, my E prime is here, my F prime. That's not prime, it's F prime. There we go, Mr. Snell is there. So there's my new triangle. Maybe I'll do that in orange. Shoink. Wait, I have a line tool. What am I doing? Use technology. There we go. Line, tool, orange. Yeah, close enough. My line right here needs to be right there. Okay, cool. So we've translated. Then what do we do? That was step number 1. Step number 2, Emma.
Then you're gonna want to not dilate it. Rotate it.
Rotate it. Yeah, rotate it around which of these points?
At D1 first, right? Or C.
D prime. D prime, C, yeah. And how many degrees are we going to rotate by? 90 degrees, 180 degrees, 36.9? I don't know.
Probably 50 degrees.
Not quite. So if you look at this line right here, that line should eventually map onto this line. So this many degrees is how many degrees?
180.
Yes, perfect. So we'll say rotate 180 degrees. It doesn't matter counterclockwise or clockwise because it can be the same thing. We'll just say clockwise, sure, why not? And you said around, or usually they use that word about point, I'll say D prime. It could have been C, it's the same thing. So if we do that, that means that this length was 1, 2, 3, 4, 5, 6, 7. So go down 1, 2, 3, 4, 5, 6, 7. And we have, this is our new point. I'll call that E prime prime. And then, well, that one is a right angle. So this point must be over here at F prime prime, and D prime prime is the same point as D prime because it's on the point of rotation. So that means using, I don't know, sure, black. My black, shrink. Yeah, and I'll have to draw it over here and then move it back. This black triangle, which is hard to see because it's slightly overlapping with our red triangle, is our new triangle. What do we do next? Or maybe we can't do anything. Maybe we can draw a conclusion. I don't know. What do we do? So 3 hands, no new ones though. Give it to Jade. She did a correction of a full answer. So yeah, Jade.
Would you dilate it, aka multiply, by 1/8?
You're really close. So so you do dilate, but you actually dilate it. It was originally 7 and you want it to be 8, so by 8/7.
8/7. Okay.
But that's like this step you don't have to do. And you were like, that's awesome that you said yes. It is a dilation of would that be 1/7 more, I guess. But the whole point here is we're not allowed to use dilation. We're only allowed to use translation, rotation, reflection. And there's no way to get from E double prime, D double prime, F double prime to that original ABC. So we're done. We can't get there. So the answer here is no. No, they're not congruent because we use all of the 3 transformations that we're allowed to, and we got close, but they weren't the same size. Can you guys give me a fist 5? How well do you understand why these are not congruent? Okay, there it is. Everyone's giving me 4s and 5s. So that's the main property that you need to know today. Let's now move on to this cool thing. All right, this is a puzzle that is like super famous. If you guys have seen it, don't spoil it for the rest of us. All right, so I'm giving you 2 triangles. There they are, A and B. So notice that triangle A and triangle B have the same side length, the same hypotenuse, etc. So let's go ahead and count A. A has 1, 2, 3, 4, 5. B has 1, 2, 3, 4, 5. And you can even kind of just visualize it, eyeball it. A and B have the same other length here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Notice also that they have the same internal shapes. Let me get rid of all of those tick marks. Go away, tick marks. Look at the shapes. Let's first look at that red shape. The red shape is exactly the same. I basically pretend that I cut this out with a piece of red paper and I just moved that around. It is a congruent shape. I promise you 100% these colored shapes, that is not the error here. They are the exact same shapes. That red shape was just moved up here. That green shape was stayed the same. That yellow shape moved down a little bit. That blue shape moved around a little bit. But here's the weird thing. We now have a missing block. We shouldn't have a missing block. It's as if I have created more space, or maybe I've lost space depending on the direction of the transformations. So what's going on here? I mean, they look like that the big triangles should be the same, but somehow I'm missing or I'm adding on an extra piece here. How is this possible?
Are you saying like if to make it not have that one block missing?
Yeah, so can someone explain why we're missing a block all of a sudden? If these two big triangles have the same length and height, probably the same hypotenuse, I would guess. I don't know, but we haven't calculated it. Yeah, we're somehow missing a block now. Or if you go from B to A, now you have found material, and it's kind of a cool GIF. Maybe I can find the GIF, maybe a GIF of chocolate being added. I don't know if that's a good Google search. No. Optical illusion, maybe add that. Ah, there it is. This is the one I'm thinking of. All right, are you guys ready for this magicalness? Is it going to actually be a GIF though? Ah, there we go. Okay, so this is essentially the GIF that I'm talking about. I don't know if you've ever seen it.
What?
This is the same thing. Somehow you're randomly adding an extra square. How is that possible? This is the same exact illusion that I'm showing you, but I'm doing it a little bit more formally.
But those ones all add up except for you're still left with the missing piece.
You have another missing piece over and over and over again. How is that possible? You just don't get an infinite amount of chocolate. We are in the real world. Infinity doesn't exist. Infinity is only in our heads. Well, unless you define it another way, but you can't have an infinite amount of chocolate by doing this. I see two people have ideas, but it's kind of a funny looking GIF. And you can actually do this with real chocolate too once, but then once you do it again, you'll realize, oh, that's what's happening. I see Charles had his hands up first. Yeah, Charles, what's going on here?
So I'm not 100% sure, but I've played with like puzzles that are kind of like this, that there's only one way that you can put it into like a certain shape, like a rectangle. And I don't know, it's just really weird how like different pieces, like even if you make a rectangle one way, if you make it a different way, it's totally messed up. I don't know. There's just really different ways to do things. It's really weird. I'm not really sure. I just wanted to say that.
Yeah, okay. So you recognize this. Yeah, Asha, talk to us.
Well, I was because like the way just like this chocolate one and the other one you were showing us, the way that they're getting it seems to me that like the way that like you're moving around because you move around two different things and it's the same thing, that's why you're getting one, or that's why you're losing one. But
Two different things.
like, you know how like for the other one, like well you said before that the colors don't matter, right? You said that, right?
Yeah, so these color blocks, 100%, that is not the issue. They are perfectly congruent because I can prove that to you too.
Oh, right. So what I'm saying is the blue and the red, because you switched them, that's why. That's what I think.
Okay, I mean
that
I agree. But by manipulating these blocks, by putting them into a different shape, yes, I agree. We have an empty block, but I still don't understand why. Like theoretically, if I have a fixed shape, this fixed blue shape and the fixed red shape, a fixed yellow shape, a fixed green shape, if I rearrange them, no matter what, they do have the same area, but then why is there an empty block now? I still don't understand why there's an empty block.
right, because they didn't change. Like it's not like they got bigger or smaller, so it shouldn't change.
Right? Yeah. Kira, I want to hear from you.
Well, I don't know. I feel like with this kind of problem, there's two types of people. There's the type that is just like you put it together wrong and end a story, and then the type that wants to figure it out.
Okay.
So they just put it together wrong. I don't know.
They didn't follow the instructions.
Yep.
I believe that there's another way to be able to not have a missing piece, I think.
Okay. I'm going to call on Wyatt first, and I'll come back to you. He's had his hand up for a while. Yeah, Wyatt.
Okay, Mr. Sindel, I see something. So
What do you-
on triangle A, the large triangle, you see where the corners of the yellow, blue, and red meet?
Yes.
How that's perfectly on the graph.
Yeah.
If you go down to where that is on triangle B, it's not perfect. So I think like we're like the angles are different or something.
Yeah, and you're like right on target. That's basically the answer. But if there's a more formal way of doing that, and then again, look at this, the intersection over here should match up perfectly, but it doesn't. Something's going on there with the slopes. And I try to cover it up with my fingers saying the hypotenuses are probably the same too. They're not. If you eyeball it, they look okay, but they're not. And Wyatt's right on the money by saying, well, look, the hypotenuses are wrong. These points should match up, and those 2 points that I circled, they don't match. And a better way of showing what's going on here is by doing this. And sorry, let me talk to Emma first, because I did say I'd come back to you. Is there a suggestion too that you wanted to add before I ended here?
Well, yes, I agree with Wyatt's method, but I was thinking that like if you flipped around the green piece and then you put it to where the yellow one was, and then you put the yellow one over the green, I feel like it might be able to fit, but I'm not positive.
Okay, what I can do for you guys too, if you want to play with this on your own, which would be really fun if you have a printer. If you don't, you'll maybe have to get some graph paper and just do this with giant piece of paper. I have, where are we? We're in unit 3. I have this thing, which is the puzzle version of this, where you can print this out. Load Infernal Computer. I have the actual shapes where you can cut them out and then you can rearrange it, and then you'll be like, wait, they're literally just pieces of paper. They fit in this triangle, kind of. And let me show you where the trick is really coming from. If I were to draw a line from this point, and let me make this line a different color, maybe so it pops out blue. Does that pop out? If I draw a line from here to here, you'll notice if I zoom in here, it doesn't match up. In fact, there's an emptiness here. Does everyone see like there's an emptiness that's happening here? What happens if I draw a line again from this point to this point? And you can see if I zoom in right here, I'm suddenly adding something that isn't there. This area, by the way, this blank area up here is exactly 1 unit. This emptiness right here is exactly equal to this 1 unit right here. If you were to mathematically calculate what is the area of this shape, I think it is a triangle. It is a triangle. That triangle has an area of 1. It's just one that's been stretched out really, really long. That's the answer. And you can verify a few different ways as well. You can actually find the area of each of these shapes and then find the area of each of these shapes and be like, oh yeah, the the area is, there is a difference of exactly 1 unit. So that's where the optical illusion happens. And you can see, oh yeah, the slopes are obviously not the same. Like this slope for this blue triangle, for example, is 1, 2, 3, 4, 5. So it has a slope of 2/5. Well, this red triangle theoretically should have that same slope. If it doesn't, that means I've randomly had a slope and then slightly changed the slope, which is what happened. Check out the red triangle. 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3. 3/8 is not the same thing as 2/5. If you do the decimal, 3/8 is 0.375. 0.375 and 2/5 is 0.4. These are not the same number. They're not the same slope. They're close, which is why when you eyeball it, it looks okay, but it shifts the slope a little bit. So now you know the solution to the puzzle. I can let you play around with it as well. Just thought it was kind of a cool congruency little thing that you guys could learn. So whenever you see this chocolate GIF, which I will be posting on the website as well, so you can show your family if you want. The way that this chocolate GIF works, and this is kind of explained in this picture down here, is the slopes aren't quite correct. You can see that this piece doesn't match perfectly, and this area of the slice that's cut out is exactly equal to 1 chocolate piece. So same type of puzzle in a different form. Yeah, Kira.
So, but do you have to like specially cut it so that the area is the same?
You do. There's a very specific slope that you can see
Oh.
this person is doing right here, that makes it look like it's okay. And if you, the way that the GIF works, you can see there's such low frames that this slope of this second piece doesn't quite match, but they just kind of skip a frame and then they say, oh, yeah, pretend the slopes match. And that's why the GIF can repeat over and over again. It's really fun to play around with, but let's go ahead. And I did promise I would show you an example if you wanted to. Is there anyone with a thumbs up? Do you want to see a practice example? Okay, let's do a practice example on Khan Academy. Let's jump over here to, not algebra 2, but to geometry. Let's go and pretend that I'm a student. This is the congruence and transformations problem. Let's go to the student view. Go computer, go computer. All right, so oh yeah, I've got 2 in a row so far. I'm doing good. Here's an example. So Tammy was curious if quadrilaterals A, B, C, D, and F, G, H, E were congruent. She was able to map one figure onto the other using a reflection and a translation. It looks like she, what did she do first? She reflected it first up here, and then she translated it. So far, so good. Okay. Tammy concluded, I was able to map quadrilateral ABCD onto FGHE using a sequence of rigid transformations, so the figures are congruent. What error did Tammy make in her conclusion? And there might be no error, but one of the choices is she didn't use rigid transformations. Well, she did. She used a reflection in the translation, so it's definitely not A. She did use rigid transformations. B, it's possible to map them using a rigid or using a sequence of rigid transformations, but the figures aren't congruent. That doesn't make sense. I literally told you in our notes over here, where are they? If you use a rigid transformation, then they are congruent. So there must not be an error. Let's check. Yeah, there was no error in that one. Let's find one that there is an error. This one, there is an error. Okay, so we're talking about Molly. She's trying to map quadrilaterals A, B, C, D, and E, F, G, H. What did she do? She looked like she did a translation and then a reflection. She reflected this dashed line onto the solid line. What error did she make? Okay, so there is an error in this one. Let's read A. One more transformation, a rotation would map them. So they are congruent. So if you somehow rotate from this dashed line to this solid line, then they would be congruent. And most of you should be nodding your heads. No, a rotation from here to here won't work. B, one more transformation, a reflection would work. And hopefully you're nodding your head. No, that doesn't work. Oh, she's actually, this is a correct solution then, because in order to get from here to here, you'd need some sort of some vertical stretch. I thought there was going to be an error in terms of, she's making the correct assumption here. They're not congruent, because if you reflect it onto here, this point comes right about here. It doesn't come up to their correct point F. So sorry, there is no error. It's the same thing again. I want to find one where there is an error. Let me retry this.
Yeah, I
go
was
back,
gonna say,
retry.
Mr. Sindel, I'm pretty sure that's, well, I thought it was right at first because like if you would reflect it, like it would be there, but it wouldn't, like the points just don't match up.
Right. Yeah. Okay. Let's see if I can find another one. And if you guys want to just do the homework and ignore me, that's a good idea too. These go pretty fast. Helena. She's saying that they're not congruent. What did she do? It doesn't tell you what she did. We just have to look at her picture. So looking at her picture, it looks like she took this QRST, this shape that's pointing up and down. It looks like she first rotated it and then she gave up. She rotated R to right there. She rotated T to right there. And she got this dash line. She's like, hey, that dash line doesn't match onto the solid line. And she gave up and said, they're not congruent because they don't match up. Well, I don't know. I think that we might be able to map them using a rotation or reflection. I think one of these two might work. A rotation or a reflection. Which one of these would map it? Actually, this one is actually kind of a hard question because you can see that this S point, which is, I guess, R prime. Wait a sec. What is going on here? Is this line really saying R went all the way over here? Because that's not R. R should be a nice tiny little angle. Oh, I think that there is an arrow here and then this arrow goes here. Okay, never mind. If we zoom in here, the end of the arrow says, yeah, R does end up there. It's hard for me to see the color there. Okay, so far so good. But this point here, even if we reflect this across line QX, this point won't be reflected onto Z. So it doesn't map onto it. So these two shapes are not congruent. And I think this is another, okay, let's find one that there is an error. Ooh, this is an interesting one. A and B are on the same circle. They are the same circle. Well, this is too easy. If they're the same circle, then they are congruent. Okay, cool. Oh, so wait, he's saying something that's incorrect. Alex is saying circle A and circle B have no sides or angles, so the circles are not congruent. You can have any shape that has any curve congruent as long as they map onto each other. You don't have to have a side. So Alex, finally, we do have our first error, our first student error. The circles are congruent. Any shape, even with a curve, can map onto one another. So, they made an error, yay. Okay, well, I think I've done enough of these to where hopefully you can do them now. And if not, I'm here for the next 5 minutes and I have office hours between like 2 and 3 if you need me. So good luck, try them on Khan Academy. You can turn off your cameras for 5 minutes, be doing work, get your homework done so you don't have it tonight.